When you evaluate, you're plugging in for x. So if I have to evaluate x at -3, all I'm going to do is everywhere I see an x, I'm going to put an open parentheses. And inside that open parentheses, I'm going to evaluate at -3. So I'm going to put a -3 in there. So now it's just order of operations. I've got to do my exponents first. -3 times -3 is a +9. Bring down the negative. Multiply, I get -21 minus 1. If I put those two together, I get -30 minus 1. Therefore, my answer is -31. You try this problem. Finding the domain and range of a quadratic, and I know it's a quadratic or a parabola because it's x squared. So here's a hint. Your domain on a parabola is always all real numbers, or from -infinity to +infinity, and I'll show you why. The range deals with the y-intercept, so there's a couple ways we can do this. So the range, I want to know where it crosses that y-axis. So if I was to graph this, and I looked at the y-intercept, which means I plug in a 0 for x. So if this becomes 0, I have +2. So my graph is going to be something like this. Okay, the other way you could do it is just go strictly into your calculator and in your y equals, put in this formula. And so now all I do is the range is from the bottom of this graph, well the bottom of this graph is at 2, to the top of the graph, and the top of the graph goes on forever in the positive direction. So there's my domain and there's my range. The reason why the domain is infinity to infinity is if I look the furthest to the left, this is going to keep going and going and going and going, and I don't know where the furthest to the left is ever going to start, therefore it's -infinity. Same thing on the right-hand side. Try this one. Find both the domain and the range. I need to sketch this piecewise function, so here's how I'm going to do it. I'm going to create two tables of values, and the reason why I chose 2 is because I have 2 right here. So xy, xy, and the first one's going to be x plus 1, and the second one's going to be -x plus 1. All right, I'm going to start with the domain. X is greater than 2. I have to start with the number given, so I go 2, and if x is greater than 2, I have 3, 4, and I could keep going. But I'm going to note to myself that x is greater than but not equal to 2, so I'm going to graph that with an open circle. So if I plug in a 2 there, I get 2 plus 1, which is 3. If I plug in a 3, I get 4. If I plug in a 4, I get 5. So what I'm going to do right now is I'm just going to graph that at 2, 3, open circle. At 3, 4, at 4, 5, and you can see the pattern continuing in that direction. This should connect. Then I'm going to do the same thing for this. If x is less than 2, so I'm going to start at 2, and numbers less than 2 are 1, 0, -1. But at 2, it's going to be a closed circle because it's equal to. So if I plug in a 2 here, -2 plus 1 is -1. If I plug in a 1 there, -1 plus 1 is 0. If I plug in a 0, I get 1. If I plug in a -1, negative times a negative is a positive, I get 2. So at 2, -1 is a closed circle. 1, 0, 0, 1, -1, 2. So you can see the pattern is going in that direction. So I have 2 separate graphs on one coordinate plane. You try this one. Evaluate. The tricky part is I have to choose which, whether it be equation 1, equation 2, or equation 3 I'm going to plug into. And it's based on the domain. So if the number is less than or equal to 1, you plug it into the first. If it's between -1 and 1, or if it's greater than 1. So -3. -3 falls in this domain, this top domain here. So I'm going to evaluate it at x plus 1. Well, instead of x, I'm going to put parentheses plus 1, and in that parentheses, I'm going to put a -3. Therefore, my solution here is -2. I'm going to change this one a little bit so I have a different domain. F is 1. So, does it fall? Is it less than -1? No. Is it between -1 and 1? Yes. Therefore, I'm going to use this expression to evaluate. Instead of x, I'm going to put parentheses, and in that parentheses, I'm going to put the number given. Therefore, 1 squared is 1. I want you to try, let's change this up a little bit. Let's make this f of -1 and f of 2. Find g minus f of x. This looks a lot more difficult than what it's actually going to be. What I'm really doing is I'm taking g of x and subtracting the function f of x. This piece looks confusing. So let's just go ahead and do this. G of x is right here, so I'm going to take 4x squared minus x plus 2. Then I'm going to subtract f of x. Well, this is f of x. X squared minus 3x plus 10. And it's important to use parentheses. I probably should have put them here as well. Well, there's nothing to distribute here, so I can just take the parentheses out. Then I'm going to distribute. That gives me negative x squared. Negative times a negative is a positive 3x. And a negative 10. So now when I combine my like terms, I have this x squared and this x squared. So 4 minus 1 is 3 with the label of x squared. Negative x and 3. So plus 2 and the label x. Plus 2 minus 10 gives me a negative 8 for my final solution. You try a problem like this. Find f of g of x. So this one's a little bit more difficult. I like to write it f of g of x. These two things are the same. So what I'm going to do is I'm going to replace the middle. What is g of x? G of x is x plus 3. Now I'm going to evaluate that at f. So here's my function for f. So if I rewrite my function for f, and everywhere I see an x, I put a parentheses, minus 2 instead of x. So this is f of x right here. Again, I replace the x's with parentheses. And then I'm going to put this expression in to evaluate. Okay, this piece right here, I'm going to go ahead and do it off to the side, because what I'm looking at is x plus 3 times x plus 3. However you want to solve that, I'm going to use the box method. Xn plus 3, xn plus 3, x squared, plus 3x, plus 3x, plus 9. So this piece right here is x squared plus 6x plus 9. I can distribute negative 2x. Negative 2 times 3 is negative 6 plus 1. So my final answer, I'm going to combine like terms. I have x squared minus 4x plus 4x, because 6 minus 2. Then I have 9 minus 6 is 3, plus 1 is 4 for the final answer. You try 1. Again, I like to start out by writing it f of g of x and then plug in for the middle. Finding the x-intercepts. X-intercepts, or these are called solution, is when you plug in a 0 for y. So 0 equals negative 2, absolute value x plus 3 plus 10. Now my goal is to isolate this piece right here. So I'm going to subtract 10 first. So I have negative 10 equals negative 2, x plus 3. Next step, divide both sides by negative 2. So I have 5 equals x plus 3. Now from here, I'm going to set up two equations. One that equals a positive 5 and one that equals a negative 5. So I'm just going to take this piece, x plus 3, and write it twice. Now to solve, minus 3, I get x equals 2. Minus 3, I get x equals negative 8. So you can either write them like that, or you can write them as x-intercepts, 2, 0, and negative 8, 0. Try this problem.